Okay, so I shared this with a student this morning, um, and it occurred to me, I never recorded this and put it out on YouTube so that others who might stumble across it might find it helpful. So anyway, it deals with the fact that so many students, so few students really understand, many memorize it correctly, but understand what in the world is the sine of 0 degrees or 0 radians for that matter, and as well as the cosine of 0 degrees or radians. And what about the sine of pi halves radians, the cosine of pi halves radians, and all the multiples of pi halves, those 90-degree multiples, the sine of pi and the cosine of pi, as well as the sine of 3 pi halves and the cosine of 3 pi halves. And of course, the sine of 2 pi will be the same as the sine of 0 because 0 and 2 pi are coterminal angles. Now let's take a look at this diagram here where I have the three sides of a right triangle labeled according to the angle here at the origin. Opposite, adjacent, and hypotenuse. Now remember that sine is the ratio of opposite to hypotenuse. So O divided by H will be the sine of the angle. Okay, now as the angle decreases, as the angle approaches 0, notice the hypotenuse isn't changing. The hypotenuse stays the same, but as the angle approaches 0, the opposite side length also approaches 0. So at an angle of 0, and I can't get it exactly right there in this um, program, but can't get it exactly to 0, but the point is still that when we get the angle down exactly to 0, this opposite side length becomes 0. So we have the ratio of opposite divided by hypotenuse, and if it's opposite divided by hypotenuse, that opposite side is literally 0. Now this is a 0, not an O for opposite. That's kind of misleading, but 0 divided by anything is 0. Now let's take a look at the cosine. Okay, the cosine is the ratio of adjacent to hypotenuse. So as the angle approaches 0, when we get down to 0 degrees or 0 radians, look what happens. Adjacent is equal to hypotenuse. So the the cosine of 0 is adjacent over hypotenuse, but adjacent and hypotenuse are equal. So, well, I'll go A over H, and then you can think of this as an O or a 0. It won't really matter. But that equals 1 because the adjacent equals the hypotenuse. This here was because, and I should put OPP over HYP there. And that is because OPP equals 0. Opposite equals 0, and so the ratio equals 0. Now let's take a look at 90 degrees, which is pi halves. As we approach 90 degrees, you may be catching on here, the sine, look what happens to the O, opposite divided by hypotenuse. When you get to 90 degrees or pi halves, O and H are equal. So if O equals H, we've got opposite over hypotenuse, but opposite and hypotenuse are equal, so that ratio equals 1. And that's because opposite equals hypotenuse there. And the cosine, well, look what happens to the adjacent side when we get to 90 degrees. The adjacent side equals 0. So the cosine of pi halves is adjacent over hypotenuse, and that's going to be, because adjacent now equals 0, that's going to be 0. So the cosine of pi halves is 0. You don't need to memorize these, folks. They actually make sense. If you see how it makes sense, you can understand it. And now, how about the sine of pi? We have to think a little bit, when we get out to pi, come back around here. Well, when we get to pi radians, 180 degrees, the sine, look what's happened to O again. The opposite side is 0 again. So the sine of pi, again, just like it was at 0, the opposite side length is 0. So the sine of pi is going to be 0 again, because the opposite equals 0 again. So the sine of pi is 0 again, for the same reason here. Opposite equals 0 again there. Now, how about the cosine of pi? The cosine of pi, well, it looks like A and H are equal, and they are equal in magnitude. However, the O and the H can have a positive or a negative sign. So in this case, to the left of the y-axis, the A is negative, and the O is, the O is so positive, but the A is negative. But H is always positive. So at 180 degrees, A and H have equal magnitude. However, oops, let's see. So we've still got adjacent over hypotenuse, because that's what cosine is. But in this case, the adjacent is the opposite of the hypotenuse. So if adjacent and hypotenuse are the same magnitude but opposite, that ratio will equal what? Hopefully you're thinking and understanding at this point. -1. So that's why the cosine of pi is -1. And now I should be able to blitz through the sine and the cosine of 3 pi halves, because at this point you're probably catching on. Come on, drag the right thing down here. Okay, so 3 pi halves, notice this time it's the O. This time it's the O that, oh, you don't want to overlap the H. This time it's the O and the H that have the same magnitude, but now it's the O that's negative. So O and H are opposites. Same magnitude, but opposite signs. So we've got opposite equaling the opposite, opposite equaling the opposite of the hypotenuse. So that means that opposite over hypotenuse will equal -1. So the sine of 3 pi halves is -1, and the cosine of 3 pi halves, looky here, the adjacent side is back to 0 again. So that numerator adjacent is going to be 0. So this is going to be the same thing as we have up here, for the same reason. The cosine of 3 pi halves is going to be 0. And hopefully that helps explain, hopefully that does explain and helps you understand these special angles whose sine and cosine are, by the vast majority of students, simply memorized, but they are very understandable.